Welcome all. Good afternoon. Today we are going to cover some of the new methods which are majorly used for the complex systems. These are very special methods generally used for the complex systems like aircraft design, spacecraft design, where you generate the products for the next 50 years. So you need to spend a lot of time in gathering the information, gathering the requirements, and you are designing the product which will be there for the many years ahead. So during during development process, you need to spend a lot of time in generating the methods. That's idea generations. We will see what those are majorly used in the aircraft industry. Not only the aircraft industry, it's a more complex systems. Wherever you feel it's a complexity, the system which has the many subsystems, and even those subsystems may have the subsystems, and then probably components, and the interaction between the one subsystem or one component to the other component, it's very complex. So in such kind of the systems, uh, we use some additional care is required basically, and there we use the some new techniques called as the functional design and TRIZ, TRIZ, and axiomatic design. TRIZ and the axiomatic design people are using for the some other products also. Those are the uh, kind of recent methods which are developed during the 1950s actually. We will see those things. Okay. In the last class we had a discussion on the different generation methods which are shown in this slide. Yeah, we have different methods and we had a discussion on these methods. First one is the scamper, second one is the brainstorming, mind mapping, synectics, storyboarding, role playing, attribute listing, and visualization. These are the very commonly used methods, but probably you could have understand that some methods probably it's kind of repetition. It's kind of the repetition. Suppose if you take the mind mapping and the visualization, more or less same basically. Same in the sense, visualization, as the name says, visualization. That means you need to have something to see on everyday basis. When I worked in Rolls-Royce and the Honeywell, they always keep, whenever there is the challenge, they keep some posters, and they make that posters visible for the many teams. So by seeing that posters, you start thinking. Probably your mind unconsciously or consciously or unconsciously, probably it will think for those problems, and probably you may come up with some solution. So that's where visualization and visual prompts are basically helping the people to get some ideas actually. Even in the mind mapping, more or less same thing. But thing is, in the mind mapping, what you are doing is you yourself is making a map, making a diagram with the system, and whatever it comes to your mind, you are putting that in a paper or putting that in a poster. So some systems are interconnected: mind mapping, visualization, and again storyboarding and the role playing. More or less some similarities you can see there. Storyboarding, we are making a kind of a story, having some pictures and some information. You will try to make a kind of the story basically. Similarly, on role playing also, you could have understood that basically you feel as such you are taking that role of a component, and then you will see what are the challenges you will face when you are going to connect with the other component or integrate with the other component. So these are the generally used methods, and these are also um, treated as the problem solving techniques. Problem solving techniques. Not only for the product, in real life also many times these will help. These will help. The details we have discussed yesterday: scamper, brainstorming, mind mapping, then synectics, storyboarding, role playing, attribute listing. These details we have discussed yesterday. Yeah, other thing, morphological analysis. This also we discussed yesterday. And apart from the discussed methods, there are many other methods which are given here. I requested you to go through this site. Actually, I missed to send the presentation. I will send the presentation today so that you can work sometime, go through this website. Their clear explanation is available for each and every method. And as we discussed, these are some of the methods, but it doesn't mean that this is the entire list. If something comes to your mind, it's a kind of the new method, maybe we can propose that one. But many of the things could have been explained in some of these methods. If not, then probably yes, you can come up with your new method. Okay, after having a discussion on the general methods, let us spend some time on the complex systems. Generally, there is a new approach. We call that as the systems engineering or system engineering. This is widely used for the designing the complex systems. A complex system, as I mentioned earlier, you have the main system, and that main system may have the many functions or many duties. Okay. Then probably you need to divide that into the subsystems and work for the subsystems. That's we have seen in the last method section. The same thing here, but there is a new name for the approach which are generally used for the complex systems. It is called as the system engineering approach. This is very, very important, and many industries follow this, especially for the new product development. Whenever you are working with the development of the new product or the modifications in the existing product, we follow this approach, which is called as system engineering approach. Okay, what is this system engineering approach, and what the difficult tools they use? We will have a discussion now. System engineering approach is the kind of the interdisciplinary field. It contains the different engineering and science students basically. Field of engineering and engineering management that focuses on how to design, integrate, and manage. Here, these three are very important: how to design and integrate the different components, and how to manage. So, this approach is useful in all the phases. It is useful for designing, integrating, and the managing the complex systems over the entire life cycle. Uh, Hopefully you remember that what is a life cycle and all. Okay, so this is the interdisciplinary plan, as name indicates. So basically they will have the many people with the different skills, and people should coordinate, integrate with the different people actually. Okay, here what the meaning of a system? Here we need to understand the system. Thermodynamically we know system. What is a system? System is something which you are concentrated on understanding. You are going to understand that. Similar way here, a system is a collection of different elements, and that together produce results. That results which is not obtainable by the individual elements. So it's a collective results basically. We all know that. Individual elements we call that as the component, and you integrate the components, then you will end up with some subsystem, and you integrate the all the subsystems, you will get the complete system. Suppose if you take the aircraft, the main function of the aircraft, carry the people, or the that's for the civil aircraft. The main function is You need to transport the people from one place to the other place as quick as possible, as convenient as possible. These are these major function. To attain that, there may be many other requirements. You need to take the people. So you need to have some way of keeping them, making arrangement for sitting, and you need to have something to take off or take the people. Some power is required to push the system, so you need to have the propulsion system. So these are the various systems, subsystems. If you see the aircraft as a system, and all these other individual systems are called as the subsystem. And subsystem may have the again many parts. Similarly, if you take the example of the human being, if you take the human being as the system, human being has the many subsystems. You have the head, you have the hands, you have the legs, and you have other parts. Each one has the its own duty, and its own function. Function is nothing but activity. And when you integrate all these things, and that becomes a kind of the system. So system is nothing but a collection of different elements which together will result some will produce some results. Okay. In the system engineering approach, there are four major steps we follow. One is the requirement analysis, second one is the system analysis control, third one is the functional analysis and allocation, fourth one is the design synthesis. Each step is from the name you can understand what it is actually. Requirements analysis. We all know that before the design you need to know about the requirement. Unless you know the requirements, what do you design? So before the design, you must know about the requirements. And requirements analysis, as the name says, it is the analysis of the requirements. What does it mean? Analysis in the sense, you need to know there are different, probably down the line, you will have a separate course for the system engineering, especially in the product design too. You will understand more about the system engineering approach. But at this moment, just keep in your mind, analysis, requirement analysis, during the requirement analysis, you need to have the very, very critical review of the requirements. You need to know what kind of the requirement. There are many types of the requirements. Some requirements related to the performance, some requirements related to the function, some are related to the safety, some are related to the regulatory requirements, some could be kind of the special requirements. So you need to understand each and every requirement. What they do is they will bundle the requirements into different categories, and from there they will they will make the subsystems, and that requirements will be flown down to the bottom level. Suppose what I mean is, you have the system, next level is the subsystem, and probably next level is probably subsystems, and the last one could be components. So requirement analysis, during the requirement analysis, you need to understand the requirement on the different levels. System level requirements, and probably from the system level, if you know the subsystems what you are going to work out, then that requirements should be flown down to the subsystem level, and subsystem to the components level. Okay, that all you will understand a little later in the another subject. But at this moment, just keep in your mind, the first step is the understanding the requirements very, very clearly. You should know, you should question yourself whether this requirement is needed. Whether customer, all these requirements you will get it from the customer. You all know that voice of customer, what we have discussed in the module 2. From the voice of customer, you know the customer's requirements. Apart from that, if there are regulatory boards, for the industry, aircraft industry, we have the regulatory boards like FAA and ESA, EASA. Those are the some regulatory boards for getting the license to your product, you need to obey their rules and regulations actually. So some requirements will come from the regulatory board, some systems from the safety as we discussed actually, and some requirements from the performance function, and some special requirements from the customer. So you need to the first step is the understanding the requirements, and the second step is the system analysis control. This is the kind of the overall step basically. I will show more details in the next slide. Control, what does it mean? Control is, you need to know, okay, you're making the system that will execute, you are expecting that will execute your function, or it will execute its work, but you should know whether the output, whatever the output you are getting, is in line with your expectation. If there is any change between the expectation and the result, then you need to give a feedback system. So that entire system we call that as the control. So system analysis, you need to analyze the system performance, and you need to give the feedback of the system to the different subsystems or the components. So that is the system analysis control. Next one is the functional analysis. We will spend some more time on the functional analysis. During the functional analysis, we need to understand, okay, these are the requirements. To meet these requirements, I am developing my system, and that system should fulfill the functions. Okay, fulfill the customer needs. Okay, so that needs, that's requirement. These requirements, how you are planning to make your subsystem, that is called as the functional analysis and allocation. And once you are clear about the functional analysis or allocation, then you will start your design synthesis. Here you will know some input, then I will show some more details in next slide. This is the overall system engineering process. As we discussed, requirement analysis is the first part, second part is the functional analysis, and third part is the design. So generally we can't really do directly from the analysis to the requirements to the design. In between we will make the very systematic way of the various functions required to meet these requirements. And for that function is nothing but activity or the work, what the real work. Suppose the example what we have taken, human being. Suppose human being, you are designing the human being. I'm just saying a very simple example for understanding. For a human being, you need to have a system for seeing, you need to have some system for doing work, you need to have some system for the movement, you need to have some system for the sensing. So all these are the functions. Okay, functions in the sense walking, seeing, probably digesting or getting the energy. So these are the function of the human being, and for each function you need to have the subsystem basically. Okay, so that is the analysis. So this is the requirement, and to meet the requirements, what all the functions required, you need to look over. For each function, you need to look over what the existing alternatives. Once you know the alternatives, then you need to select the proper one. So there you can use all the methods whatever we discussed yesterday. You need to write the different alternatives and look for the which is the better one, and different combinations, all that you can do. So requirement analysis, functional analysis, design systems, and on top of these things, system analysis and control. This shows the information flow. So from the requirement analysis, information flows to the control. Similarly, from the control, it goes to the analysis. It's a two-way. And this is the, from the requirement analysis, you make the functional analysis. And from the functional analysis, you make, okay, I'm making my function, I'm designing my function. That you need to again compare with the requirements. So this is called a requirement loop, and this is called the design loop, and this two-way communication is for the majorly for the control. And this one is the once you have designed your system, you need to verify. This is called a verification loop. Verification. How do we know whether design system is meeting my requirement? So that for that purpose, this is the verification. So if this is the entire process, and for this, it's a kind of some inputs will be given, and ultimately it is expected to return some output. Okay, and again for giving a small easy analogy, it's something like your computer system. You are designing some computer system. This is like your CPU, and this is like your input, and this is your output. In the CPU, generally you know that there will be different, in the first year probably, for simplicity, we will say CPU has the different components again, control unit, ALU unit, memory unit, like that. Arithmetic and logical unit, you have one system, and memory, for memory you have another one probably control systems. The same way here. So there is some input and there is some output, and this is the entire system. Basically, this is the actual working system basically. Yeah, here I just have mentioned different uh, different things what you do in different phases. Requirement analysis, as hopefully it is visible to you. Anyhow, I will forward this presentation to you. And again, this I have taken from the Wikipedia only. This is directly available in the Wikipedia. You can just Google Wikipedia system engineering. You will get this complete information. Basically, yeah, in the requirements, there will be requirements on the mission requirements. There will be requirements from the environments, and functional requirements. I have already mentioned you. Functional requirements, performance requirements, safety requirements, all those will be there. And apart from that, sometimes there will be some contract requirements. If you are supplying to the some people, then you need to have some contract rules and regulations. So that's also part of the requirement. So this is the first step for anything. For anything, this is the first step. For the life cycle, this is the first step, is the getting the requirements. And then, before design, you need to work out the functional analysis. As I mentioned, to meet this, what I need, that is called as the functions. What functions are required to meet my requirements? Once you know the functions, then you can design your system. Suppose you are working, again I am giving a small example again. Suppose you want to go from one place to other place. Okay, for that you are looking for some vehicle. Okay, in that vehicle, this is the requirement. Suppose main requirement is you need to move from one place to other place as quickly as possible. There is something like that. Now, for that, what you need, what all the functions require? Function is I need to sit, I need to have some power to move from one place to other place. It should have it should take me in a safer position. So those are the functions, each function. And for each function, you need to look for the equipment. Now, okay, sitting. Then you need to think about the, okay, whether you want to sit and go, or stand and go, or lay down and go. That's basically based on that. You need to design your component according to that requirement and function. During that time, you can explore the many alternatives and select the better one. Okay. Hopefully you understood what is the requirement, what is the function, what is the design. And during all these things, some feedback is required. So that is feedback control system here. Control system, it takes the input from this and checks whether it's meeting the requirement or not. If not, again it says no, it is not meeting my requirement. Then again you need to modify. So all this is a kind of the loop. It is a kind of the loop. You work, you work on this, you give some input to this, and you work on this and give this input, and probably again there may be some changes, again you need to go back, so it is a kind of the loop. Okay, so this requires the multidisciplinary approach. Multidisciplinary. You are working on one component, but complex systems may have the thousands or lakhs of the components. So you need to understand the difficulty of the other person also, other component. So this is a kind of the multidisciplinary team. Team, you need to work in the different teams, multidisciplinary teams. So that's where we always say, especially for the aerospace, you need to work with the multidisciplinary mode. Okay, yeah. This is again. I'm just showing the what is a functional analysis as we discussed. Functional analysis is nothing but the analysis of the mission and the performance requirements, and translating that requirements into the activities. Activity is nothing but work, or the this is a function or activity, both are same, activity. So again, some definitions it is given according to NASA. The functional analysis is the process of identifying, describing, and relating the functions of a system. For the example, what we have taken the human being. So digestion, the digestion system. The digestion is a one function. Walking, seeing, hearing, all these are the functions. All these are the functions. So identifying the function, describing the function, and relating the functions is the functional analysis. So once you know the functions, then only you can develop the components. So design comes in the third step. Yeah, again, it's the same thing. Always functional analysis, it's a top-down hierarchy. You should know about the what is the function of the system. Then understanding to meet that function, you need to know about the functions of the subsystems, and from there you come up with the functions of the components. So this is a functional analysis, and the other one is a functional design. Functional design in the sense you are making the component or designing a component which can perform one particular function, that is called it's a called of the modular part of the device that has the responsibility, performs that responsibility with the minimum of the side effects on the other part. So suppose for the same example, ears, the function of ear is to hear. It should not disrupt the other function. Okay, so that's called that side effect. We try to minimize the side effects always. So we need to create or design the subsystem or components in such a way that it is supposed to deliver its function without disturbing the others. But many times it may not happen. It may have the side effect. Then you need to work out with the how to reduce. Maybe that person will come and ask, okay, you are designing this, but it is affecting my performance. Then here many times many conflicts will happen. In reality, in even for the any industry, suppose you are responsible for the one component. Let us take you are responsible for the designing a compressor in a gas turbine. Probably you have come up with some new idea, and you have told it's improving my performance, everything you have told. But thing is, it is badly affecting the other component, turbines or the combustion chamber. Then you need to have a clear-cut discussion, how to reduce that. You are not supposed to say that I'm responsible for compressor, I'm making this, and I'm least bothered about the turbine. No, you can't, because you all are part of the responsible for making this system. So basically, what I want to convey here is functional design means designing a part of the subsystem which is supposed to deliver its function without affecting much the other systems. Okay, how do we? There are some techniques, visual techniques, what we use while making the functional decomposition. Decomposition means, as we discussed yesterday, we have the big project or the big thing system. You need to divide that into subsystems or subparts, small parts. You need to work out with the small parts, then obviously you will end up with the getting the solution for the big system. So that's what we have seen here. Yeah, here. So decomposition is nothing but splitting the big job into the smaller jobs. So big problem, you make it into parts, and again each part probably again you try to make it into sub parts. So this is called decomposition. And you need to make some component which is good, which is sufficient to deliver this task. So you need, these are the individual tasks. So you need to come up with the different components or different hardware or software which are supposed to deliver the or meet these activities. Once you design, obviously you are designing the big problem. Okay. Yeah, there is one tool we use. This is called as the function diagram. It is again similar to the one what we discussed for the computer system. You know, when you are initial stages, probably someone could have told that probably you could have drawn some picture saying that this is my input, this is my output, this is the CPU. For input, again, maybe there are different components, probably mouse or the jockey or keyboard. Those are the different input devices. Similarly, output devices, you could have studied that like monitor, printer, all those are the output devices, and CPU. So there you could have used some pictorial representation of the input, CPU, and the output. The same way here, function diagram. It is a kind of the uh, pictorial representation of the main function to sub functions actually. Suppose here you have something, maybe in the next slide I will show you. Yeah, what we do is we will have a pictorially represent some function with a kind of a small box like thing, and you can give some function number, and you can mention the function title. For simplicity, I'm trying to say the same human being example. Human being, you are designing a human being, and we just told I just told that that has different functions. What are the different functions? One is the seeing, one is the hearing, another one is the walking. So these are the different functions, and if there is any connectivity between one function to other function, that generally we will show with the arrows. So the function, probably hearing is a function. For hearing, what are the input and what is the output we expected? This is the input and this is the output. And if it is connected to something else, and the that previous function may give the some input to the your present function. Okay, and it may give some information to the next function. So all these we will represent with the arrows and some boxes. So this is called functional diagram. This is very important, especially when you are working with the complex systems. um, Generally when you go with the aircraft systems or the space systems, um, you will see, probably we will arrange a guest lecture who really worked on that, and they will show you when they are making their designing. The first step is requirements anyhow, that's the first step. Next step is the functional design, functional analysis. They need to identify the function. For each function, generally we will have some picture like this. These are called as the functional diagrams. Okay, this is the one function, these are the different functions, and sometimes it may be parallel functions, and sometimes it may be alternative function. Alternative function means, if it is not there, you can use this. That is called alternative. alternate function. So here parallel functions, this is like suppose I'm just giving example again quoting the same, hearing and seeing, probably those two are parallel probably, then you can say those are the parallel functions. But hearing probably instead of the regular ears, maybe something else. If you have alternate system, then you need to put that as the alternative function like this. To differentiate the parallel and the alternate, we use the some gates. We call them as the AND gate and OR gate. AND gate is for the parallel function, and OR gate is for the alternate. Or you all know that OR means either this or this. So alternate, when there is alternate function, we just show them as the OR. Okay. And especially in the aircraft industry, redundancy is very, very important. Many times when you are designing, you need to look for the alternate. If something gets fails, you need to have the alternate system which caters to the same function. Okay, redundancy is required. So in that case, we show them another function or alternative function in along with the main functions. So we use the AND gate and OR gate here. Okay. It looks a little tough to understand here, but bear in mind, you just try to understand what is the function diagram, what it contains, what the input, what's the output, and how it works. Probably at this level we don't really bother, but we need to know what is the function or what is the work, what is the activity we need to do. Once you know the activity, then you look for the your components. Okay. It's the same way. The functional diagrams probably you may do with different levels. Top level, or what I mean top level means system level. System level functional diagram might be available. From system level, you can create the functional diagram for the subsystems, and from the subsystems you can create the functional diagram from the for the individual components. So all that you can show, you need to show, you need to understand very, very clearly, very, very clearly. It's a lot of time is invested in making this functional analysis. While making the functional analysis, you need to see whether it's, if there is, first of all you need to see whether it is meeting my requirement. Second thing is you need to see whether it is needed, is it mandatory to do this way. Then you need to look for the alternative ways. From the alternative ways and keeping the requirements in mind, you need to select the proper one. That's in the next step. But you need to draw kind of the different tools are available. Different tools like function diagram will give you kind of graphical representation of your thoughts. Okay, there are two ways: decomposition by the sequence of the user actions. Other one is the decomposition by the customer needs. Either way, you can follow those things. Okay. Yeah. What's the use of this? What's the main purpose of functional analysis is, first thing is you need to understand the various activities or functions required to meet the requirements. That's first and foremost requirement. Second thing is, in this process you will understand if there are any critical processes for which you do not have the solutions, ready-made solutions are, may not be available. So identifying the critical process or critical function, that is the very important task while making the function design, functional analysis. So you need to identify the critical functions or critical issues. Then we need to highlight and we need to look for the solution for that. Suppose you don't have the solution for that at all, then you need to look for the alternatives. Okay, so identifying the activities and identifying the critical activities is the major important step while making the functional analysis and design. Okay, so I'm stopping at this moment. I'm pausing a minute. Uh, Please let me know if you have any difficulty in understanding the functional analysis and functional diagrams. If there are no questions, then we will go ahead with the other methods, which are getting very wide popularity in nowadays. One of them is the trees, and the second one is the axiomatic design. We will discuss those things. And before that, let me know if you have any difficulties in understanding or any clarifications or any doubts. Okay, if there are no questions, I will continue. Okay, this is the another methodology which is very widely used in nowadays, especially for the innovation solutions or the what we say is problem solving, inventive problem solving. TRIZ is the Russian acronym. Basically, it is developed by the Russian scientist and engineer. And there is a very interesting story about that engineer. Basically, probably I will explain if time permits. He has come up with the methodology, and that is related with the TRIZ. That's the theory of something in the Russian, but the meaning of that is the in English it is the theory of inventive problem solving. Okay, and some people will say that as the theory of innovative problem solving. Innovative. Okay, inventive or innovative people use in different ways, but this is the acronym. Probably you could have seen that the T is from the theory. RIZ, it's not showing here, but basically he has kept from the Russian language. Okay, the corresponding meaning is the theory of inventive problem solving. It's very interesting, and it's really kind of a revolution. This method is I really loved this methodology, and many industries, you know, especially in the all the big industries, they are spending a lot of time, and they are giving the training for TRIZ method, and people take this as the kind of the innovative problem solving method. Innovative problem solving method. Okay, here according to Trace, it's very interesting to know. Principles of creativity. He created the principles of creativity on the basis of the innovation. Basically, we feel that creativity means something which is not available, and you are your first time you are creating. But according to uh, his philosophy, that's also can be systematic. There is nothing like innovative. What he is trying to say is, for every problem there is a solution, but all those solutions, it's already available. Only thing is, you need to you need to modify your problem to a general problem and look for the solution. Then you will find the solution. Unfortunately, it is limited to the technical. Otherwise, probably we can use this getting the solution for the coronavirus also. From this, what he is trying to say is, no problem is there exist without solution, and at the same time, solutions are already available. Solutions are already available. Only thing is, you need to look. So it is a kind of the search. The more you search, you will find your solution. What he did is, he spent lot of time in analyzing the patents and the innovations. Then he understood there is some pattern. Even though they say it's the patent or innovation, if you really understand that design or the principles behind that, it's more or less same, more or less same. So that's what he's trying to say. And basically, what he did is, he created the database also for the technical problems. What he invented is, it's a kind of the his philosophy is, he classified all the problems. If you keep all the problems, um, surprisingly, it came around some 35 to 40 problems. And for all that 40 problems, and he looked for the patent search and the pattern in the patents. From there, he has come up with the solutions also. Solutions also. So this is very, it's kind of ready-made solution available. Okay. Yeah. Probably I will give more information in the consecutive slides. Okay. Before going anything specific here, yeah, universal principles of creativity from the basis of innovation. Okay, Tris identifies and codifies these principles. Whatever the principles of creativity, he has already codified those things and he identified those things. And surprisingly, those are not really hundreds and all. It came to 35 or 40. I'm not really sure. I have not kept the number here, but it's around 40. So all these 40 problems, and he has come up with the various solutions. Okay, and he has come up with the some tabular form. Once you know the problem, and for that problem, from the tabular form, you can find out the solution. So that's the beauty of this philosophy, TRIZ. So that's why I'm saying you, for any problem, for any challenging problem, you can try to look over the solutions from this matrix. He has come up with the matrix, and from that matrix, you can come out with the solution. Yeah. TRIZ is most useful in roles such as the product development, especially that's really useful for developing the new products and new designs and the process management. And down the line, you will learn more about the Six Sigma. Nowadays, that's the quality principles used in the many industry. Six Sigma, Six Sigma quality basically. So as probably you know that the sigma. What is a sigma? Standard deviation. Six sigma, six times the sigma. So one failure in 100 million, something like that, basically. So you need to design your system in such a way that the failure probability is meeting the Six Sigma quality. Okay. Probably you will learn many things in the down the line about the Six Sigma. But just to keep in your mind, this is a philosophy now everywhere used in the industry, especially in the aircraft industry. As well, I work with Rolls-Royce and Honeywell, GE, wherever you go for the big industries, they follow this Six Sigma policy. And Six Sigma policy, this is one of the very important method they follow for making the new designs while making the new products. New products. Yeah. So this is the problem solving. This is a technique of the problem solving philosophy based on the logic, data and research. This is what I'm trying to say. He collected lot of information from the patents, lot of information from the patents, and he put all the information in the form of a some tabular form actually. Okay, so by seeing that tabular form you can find the solution for your problem actually. So this is a philosophy based on the logic, data and research rather than on the intuition. Okay, it draws on the past knowledge and ingenuity of the thousands of engineers to speed up the creative problem solving for the project teams. Okay, as I mentioned, his story probably I think his name is mentioned here. Oh, I think I missed to mention his name. I will send that. Yeah, yeah. Oh, sorry. It's given here, I think, by engineer and scientist Genrich Altrush. I'm sorry if I pronounce wrongly. He's a Russian actually. He's a Russian guy, and a very interesting story actually. He spent lot of time in collecting and information from the patents, and he has come up with this methodology, and then he presented his methodology to the Russian president during that time, Stalin. Stalin during that time. Thing is, instead of getting the appreciation, Stalin made an argument that you have gone through the so many patents. That means you are revealing the patents information to the public. So keeping that actually allegation, he put him behind the bar. So this scientist got imprisonment for his lifetime basically. But after Stalin death, he got released actually. He was there in prison for 25 years. Just imagine the pain what he has taken. But I will share the link where uh, the complete information about this methodology is available. Okay, go through that. Because of the time constraints, I am not spending sufficient time here. But I highly recommend you people to go through this philosophy. It's really worth of spending so much time on that. And probably you may not appreciate the solutions what he mentioned during this time, but thing is once you join into industry, you really appreciate the methodology what he has proposed. Okay, yeah, the philosophy is like this. You have some specific problem. What you need to do is, there is always while design you will have a constraints. Okay, contradictions. Sometimes you may have the constraints and sometimes you may have the contradictions. What I mean by contradiction, to just giving you some example. Suppose you are getting some high stress in some of the parts. Obviously, to reduce the stress at the those parts, you always try to increase the material thickness. I'm just giving a small, very simple example. When you are trying to increase the thickness to reduce the stresses, obviously it is increasing the weight. That means when you are trying to improve something, it is penalizing the some other thing. This is called as a contradiction. Okay, so you need to understand the contradictions. Once you know the once you know the problem, once you know the contradictions, you can find the easily solutions. So the philosophy goes like this. You are working on a specific problem and you got stuck up what to do and all some place. Then what you need to do is you need to look how it is common to other problem. So this is called general problem. Analysis of the problems and analytic use of the trees database. Using this, what without that also you can use, but there are now many tools are available, database available actually. What you need to do is you need to convert your specific problem to the general problem. Once you find the general problem, definitely you will get the general solution. What I mean is, probably in that particular application, probably people have not done, but the same problem people could have felt in some other application. So that application is a kind of the general problem. Okay, and for that problem you need to see the solution, how they solved, and try to understand the solution methodology, and try to use the same solution methodology to your problem. Okay, so this is the philosophy. Specific, first step is convert your specific problem to general problem. Second step is look for the solution for the general problem, and the third step is converting that solution which is existing in the general solution to your specific problem. So this is the trees process. Okay. Yeah, this I think I covered basically contradictions I have mentioned. So you need to understand the contradictions, you need to understand the problem, then you can find the solution. Yeah. There are fundamental contradictions. All these contradictions he kept in a kind of the matrix. It's available. That's probably I will share. I will add that one two slides. I missed those slides actually. I will include those things and send you that one. Many times contradictions there you need to look for the trade-offs. So you are trying to improve something, but it is affecting something else. So you need to have a trade-off between those two. Okay. So he has come up with the contradiction matrix. From the matrix, you can find the solution. Probably if time permits, when our university opens, we can do this also kind of the activity, classroom activity. It's really awesome. You will love this methodology. Yeah, physical and you know he is trying to give the very simple examples like coffee should be hot enough, that should be to be enjoyed, but at the same time it should be cool enough so that it will not burn the uh, drinker's tongue. So hot and cool. So these are the kind of the contradictions. Obviously, you don't want to take the coffee cool because you don't like that. At the same time, it should be cool enough that it should not burn your tongue. So this is a kind of the contradiction. Such kind of the contradictions will be there in design. It's there. It will be there. It will be there. As I mentioned, if you are working on one component, probably you could have come up with some solution which is really good, but it is penalizing somewhere else, something else. Then you need to come up with some trade-off or a compromise between these two. So you need to understand what these are the two contradictions. Based on the contradiction, you can look for the solution. Okay, I think you have the class, another class. I will stop here. I think Professor Surya's class is there after, I think, 4 o'clock. I will stop here. Please let me know if there are any questions. Otherwise, we will continue tomorrow.